I got friends in New York City, 'cause everyone I know left town.
This is a concept video for linear systems with constant coefficients. So a system of differential equations, let's find out what that is. So a system of differential equations, we have multiple quantities and the rates of change of these quantities. Rates of change depend on each other. So an example would be the simple system x prime equals y and y prime equals x. So the rate of change of x with respect to time, dx dt equals y. The rate of change of y with respect to time equals x. We can extend this into more than two variables. We can have x prime equals negative yz, y prime equals z squared, and z prime equals xz. So in this case, the rates of change of x, y, and z depend on the values of x, y, and z at a given point in time. We can convert these into a vector form. We can make x prime, y prime, the vector, equal yx, the vector. In this case, we would write x prime, y prime, z prime equal negative yz, z squared, and xz, the vector. We commonly write this vector here on the left-hand side as x with an arrow on top prime. So in this way, we can turn the system of differential equations into one vector equation. In this case, we would have x arrow prime equal negative yz, z squared, and xz. So next we look at linear systems. So a linear system has no products, powers, or higher order functions involving the unknown functions. So in this case, in these cases, x, y, and z are unknowns, and time is what we call unknown. So we'll look at some examples. The first example we dealt with, x prime equals y and y prime equals x, is linear because x and y on the right-hand side aren't being multiplied, they aren't being taken as powers, or they aren't having functions applied to them. Our example here is not linear because we have the product of y and z here, and we have the product of x and z here, and we have z to a power. So that's not linear. If we look at this system, x prime equals 3xy minus 5y, and y prime equals negative 2x. This is also not linear because we have the product here between x and y. More examples, we have x 1 prime equals negative 2x2, and x2 prime equals 3x1 squared plus 4. And we can use x1 and x2 instead of x and y. The reason that's used is because with these subscripts 1 and 2, we can go on indefinitely. Whereas with x, y, and z, we have to keep making up new letters. So this is not linear because x1's being taken to a power. And if we have this system, u1 prime equals negative cosine t u1, and u2 prime equals u1 minus sine t. This is also not linear. Because this u is inside cosine, which is a higher order function. This sine t is actually okay because time is considered a known quantity, so it's okay if that's being taken to a higher order function. So examples of things that are linear, we'll go get more of those. X1 prime equals negative 2x1, or x2, sorry, and x2 prime equals 3x1 plus 4. This is linear because we don't have any of the things we are not allowed to have. u1 prime equals negative cosine t u2, and u2 prime equals u1 minus sine t. This is also linear because the higher order functions are not being applied to u1 and u2. It's only being applied to time. So another thing about linear systems, I'll just abbreviate it as LS. These can be written as a product of a matrix and vector plus another vector. So that'll be in the form x prime, so x arrow prime, so it's a vector, equals a, which is a matrix, times x arrow plus some vector, we'll call it b. So this is a matrix, and it's going to be n by n, and this is a vector. This is going to be our vector of unknowns. And this is going to be a vector of knowns. And this is just the time derivatives of the unknowns. So let's go through our linear systems we found and put them into this form. This can be written as we've shown, x prime equals y x, but this can actually be written in the form 0, 1, 1, 0 times xy. So simplifying this, we get x prime equals 0, 1, 1, 0 times x. For other examples, this one we can write as x prime equals 0, negative 2, 3, 0 times x plus 0, 4. We can write this as u prime equals 0, negative cosine t, 1, 0 times u prime, or sorry, u plus the vector 0, negative sine t. And those are our examples of linear functions. So those can be written as an equation in this form. And now when we talk about constant coefficients,